Hello, everybody. Welcome. Thank you very much for joining us. Just while everybody is joining the session, I am going to just do a little quick introduction, a little quick welcome for you, and then we will dive straight into the session. So hello, everybody. Welcome. My name is Julia, and I am the Communications Manager in the Department of Economics at UCL, and I'll be looking after this session. And I will hand over to Jack. Jack, do you just want to say a quick hi?
Yeah, hi everyone. Thanks for spending this morning with us. I'm Jack Blumenau, and I'm an Associate Professor in Political Science, and I'm Co-Director of the MSc programme.
Good morning, everyone. I'm Kristensen. I'm a Professor at the Economics Department. I'm the other Co-Director of this new MSc programme.
Thanks, guys. And yeah, just to give you a very quick rundown of what we're going to be covering today, obviously we're going to be talking about this new programme, the new MSc Data Science and Public Policy at UCL, which will be kicking off in September 2022. Jack will be giving us a little taster lecture just to give you guys a bit more of an idea about what to expect in terms of content on the programme. And then Dennis will be running us through kind of the nuts and bolts of the programme. We've got some very exciting news. Applications are open if you haven't seen that already. So if you've been waiting to apply, please obviously do go ahead and do that. And we've also got some scholarships available as well. So we'll go into a little bit more detail of that later on. But yes, a very exciting time. So without further ado, I will pass straight over to Jack to dive into our taster lecture. All yours, Jack.
Great, thanks, Julia. So hi, everyone. As I said, I'm Jack, and it's really exciting to be able to talk to you about this programme. As Dennis mentioned, this is a new MSc programme, and it's the first one to be jointly delivered by the Political Science and the Economics departments. And so we're super excited about the programme, and it's good that you're here to sort of hear about it. So I'm going to give you a brief taster lecture, give you an idea about the types of things that we're going to cover during the years, the year of the master's programme. And kind of by now, it's almost cliche to talk about kind of the explosion of in the availability of data, sort of quantitative information, sort of in recent years. This is something that you should all be aware of, and in fact, just by virtue of the fact that you're in this virtual room, there's been an increase in the amount of data available to people. But one of the things that's sort of particularly interesting about this, or sort of one dimension of the sort of the increase in this data, sort of these sources of data, is how much of it is relevant to public policy. So how much of this new information sort of helps to inform how we think about public policy. And so what I'm showing you on this screen is sort of just an overview, just grabbed from the web a couple of weeks ago, of the different types of topics that are sort of able to be addressed by using these kind of new forms of data about people and about policies and about financial markets and so on. And so, you can see here that there's sort of examples that are sort of traditional political science examples, thinking about things like sort of the level of support for different political candidates in an election. There are sort of examples from sort of typical economics questions about sort of the level of bond trading in a particular market and so on. But there are also sort of, very topical issues that are new to the agenda, or at least sort of newly emergent on the agenda. So things like climate change, migration, and then particularly, of course, COVID, where we've seen sort of the importance of being able to use data to inform public policy responses. And so, there's a huge amount of this information available. What you're seeing here is a whole load of graphs. Now, graphs are one way of trying to understand the information that we have at our fingertips. But of course, they're not the only tool that we have at our disposal. And in some sense, like the MSc, what we're trying to do on the MSc is provide you with the tools necessary to glean understanding from this sort of this explosion of information. And so the whole goal of the program is to try and develop a skill set which allows you to make sort of concrete contributions to public policy thinking by using sort of various data analysis tools. So the goal of the program, in some sense, is to train a kind of a new generation of policymakers in order to tackle these sort of evolving challenges that are associated with this sort of explosion of information, and thereby to sort of make a contribution to policymaking. by the end of the course, we kind of hope that our graduates will be able to do three main things. So the first is that we hope that they'll be able to both understand and critically to apply these kind of cutting edge data science methods. So a whole sort of roster of different methods that exist in sort of machine learning and statistics, and apply those to questions in public policy. Beyond that sort of technical skill set that we hope that our students will develop on the program, we will also expect them to develop a deep set of analytical skills, which help them to think about answering important questions in policy making. And sort of the combination of those two things, of the methods and the analytical skills, will enable you to undertake sort of independent research into complicated questions in public policy. So if you're coming from an undergraduate degree, you'll have done a little bit of independent research. There'll be a whole lot more of that in this MSc degree, and so it's very valuable if you're thinking about going into any kind of profession which requires those kind of research skills, or indeed if you wanted to go on and study for a PhD. I think one of the other things that's sort of, an advantage of presenting a course like this is that I need to do very little to persuade you that there's a huge demand for data science skills in lots of different careers, both in the public sector and the private sector nowadays. There's just a huge sort of premium put on having this kind of skill set across a whole wide variety of areas. And this is just one quote that sort of exemplifies that, which is a quote from a report by the Royal Society, where they said that data science and engineering are growing fast and broadening in scope, no longer just the preserve of highly technical STEM or finance-oriented roles in London. Data science increasingly pervades modern business, scientific endeavor, and public affairs. And so again, sort of by participating on this program, you should expect to sort of develop a skill set that's going to make you very competitive in the job market. Okay, so what are we actually going to sort of do on this degree program? Well, I think you can sort of, one way that you can think about social data science is in a sort of a decomposition of the type of questions that you can use these tools to answer, right? And so this is just one way of sort of splitting this up. There are other ways. It's one way that I thought about, which is that, social data science can be thought of as a set of tools which you can use to answer many different types of quantitative questions. So those might be measurement questions. So these are often at the core of lots of different types of social science research, which is sort of about trying to measure various social concepts from quantitative data. So these might be, again, sort of traditional how democratic are different countries, or economics questions like how productive is the economy, or what is the public's preferred level of taxation and spending on different issues, and so on. So you can think about these kind of measurement questions. Now, those are often absolutely critical to any research that we do. Similarly, you might think about prediction questions. So very often we use these kind of quantitative data sets to try and predict the level of some outcome at some point in the future. So if you think about something, the very obvious example of this at the moment is COVID. What will the COVID case rate be by next week or by next month? Sort of, will GDP growth be positive next year or negative, or in the next quarter? The example that I'm going to talk about in a second, sort of who will win the next election? You can think about these kinds of questions where we want to use the information to make a projection to some future time period. And then finally, we could think about causal questions. Now often causal questions are the ones that are of most interest to policymakers. So these are questions where we're trying to work out the effect of some phenomenon X on some other phenomenon Y. Okay, so we could think about something like, what's the effect of lockdowns on COVID transmission, or sort of the canonical example of this in economics is sort of what's the effect of an increase in the minimum wage on employment, right? So you can think about these different types of questions. And part of the reason that I want to put these up here is that if you have essentially any interest in public policy, you can almost always frame some of that interest as a question that can be answered using these kind of data science methods. So if you have some substantive interest that you've built up sort of either during your undergraduate degree, or maybe if you've worked in policy making in practice for a while, there's almost always going to be some aspect of the work that you're interested in that can be sort of approached using these kind of data science techniques. Now I'm going to focus on a prediction question, and thinking about how to predict outcomes. Okay, this is just an example from my own research from recent years, and I want to start with this quote, which is sort of very well known, but hard to attribute to any particular individual, which is that prediction is very difficult, especially if it's about the future. Well, of course, all prediction is about the future in some sense, so it's kind of silly. But the idea is that prediction is hard, right? Making accurate predictions is very, very difficult, and actually, particularly in the setting that I'm going to talk to you about, which is the context of the UK general election in 2017. Okay, now this is a good example of a prediction question because we were trying to make predictions. We were trying to forecast the outcome of the election before it happened. So it's a prediction task. We're trying to predict something that's going to happen in the future, and we have very clear criteria for success, right? Which is that we're going to actually observe the election outcome. So we're going to be able to tell how well we did in our prediction task by comparing sort of the predictions that we make to the outcomes that we see. So for those of you who have no interest in British politics, that's totally fine. I won't be offended. Let me give you some context. So the UK general election was in 2017 was mainly fought between the centre-left party in the UK, which is the Labour Party, and the centre-right party in the UK, which is the Conservative Party. And the leaders of those parties are the two people you see here. That's Jeremy Corbyn for the Labour Party and Theresa May for the Conservative Party. So in order to predict a UK general election, we need to think a bit about sort of how elections are decided in the UK. So in the UK, general elections are decided on the basis of the party that wins the most seats in the House of Commons. So if you win a majority of the seats in the House of Commons, you get to form a sort of a single party majority government. So you have, again, essentially get to have complete control of the legislative agenda, which is a very powerful position to be in. Okay. In order to sort of win the most seats or win a majority of seats, you have to think about the total number of seats in the House of Commons. There are 650 seats in the House of Commons, so you need to win 326 of those seats in order to have a majority. But in order to predict the election outcome, what you have to be able to do is not predict the overall number of votes for each party, but rather you need to predict the number of votes that each party gets in each of the constituencies. Because the way that elections are decided in the House of Commons is that in each constituency, which is a small geographic region, the candidate who wins the most votes gets elected. So it's a simple kind of plurality rule within each of the constituencies, right? So it's just, the parties stand candidates in each of these seats. The candidates who win the most votes gets to go to the House of Commons, and the party that has the most MPs gets to form the government. Okay, so if we want to predict the election outcome, then what we really need to be able to do is to predict the outcome in each of those individual constituencies or seats. So traditional election polls, kinds of ones you would see typically reported in the newspapers, those tend to be pretty good at predicting the vote shares at the national level, but they tend to be not so good at predicting outcomes at the constituency level. So they're good at understanding, what's the expected vote share for the Labour Party and the Conservative Party overall, but not sort of within each of these 650 geographic units. And so what we did in 2017 was to try a new approach. Me and some colleagues in the political science department, alongside people from YouGov, which is a market research firm. So what did we do? Well, we collected some data. The first thing that we did was collect some data. And in particular, we had about 100,000 respondents online from an online panel. And we just asked them, who do you intend to vote for in the forthcoming election? And we did give them a bit of context. So we showed respondents the names and the parties of the candidates standing in the constituency in which they lived. So, we'd tell them who it was they could vote for, and then we would ask them who it was that they would vote for. And then we also collected information on a whole load of demographic variables. So we found out the respondents' gender, their age, their education, their past political behavior, so who they voted for in past elections, and so on. Okay. So we have this relatively rich and relatively large data set, right? So we have lots of respondents and we have lots of information on each of our respondents. But then there are kind of two problems or two questions that we need to ask about this data. So the first thing is, I said, we've got this large data set, we've got 100,000 observations, 110,000 observations, something like that. Well, is that big data? In some sense, you could think that this is big data because it's a lot of observations. But of course, as I said before, what we're going to be needing to do here is predict results at the constituency level, not at the national level. So when we sort of narrow down to the number of observations in each constituency, we actually have very small data. We only have about 150 respondents per seat. And given that that's the area that we want to make predictions, that seems like it's not very much information. The other thing is that even though we have big data in some sense, we probably have very unrepresentative data, because the people who participate in this survey, the people who agree to give us responses about their political beliefs, are going to look very different from the electorate as a whole. So they're likely to be sort of more educated than the electorate as a whole, more politically interested than the electorate as a whole, and so on. And so we're going to have to be careful about the fact that that might introduce bias into our predictions, because we may actually just have good information for the particularly politically motivated people, but not for the rest of the electorate. So you can kind of think of different ways that we might approach this idea of election forecasting, given this data. So one is that we might just say, well, we've got a lot of data, let's just estimate the national vote share for each party. So we'll work out sort of how many people are going to vote Labour and how many people are going to vote Conservative from our survey data. And then we'll compare that to the previous election. So we'll see, in our survey data, it says that Labour will be up 5 points relative to the prior election. And then we might just assume, well, if they're up 5 points nationally, maybe that means that they're up 5 points in every single seat in the country. Okay, and so we could just assume that there's some kind of uniform swing across all the seats in the country, and we just add 5 to the Labour vote share in each seat, and then work out what that would mean for the election outcome this time. Okay, so that seems like one way of doing that. That's actually the traditional approach to election forecasting in most countries. The advantage of that approach is that we're going to have good estimates, or we should have pretty good estimates of the national vote shares, because we've got a lot of data. So we're going to be very certain about the national level of support for each party. The disadvantage, of course, is that we're not really making use of any local information. So we want to be able to predict the results in each constituency, but we're just going to assume that the movement from last election to this election is the same across all constituencies. And so that could be a disadvantage, because it might be that Labour are up 10 points in one seat, but are up sort of 1 point in another seat, and that could have very different implications for the overall election outcome. So that's what, the complete pooling approach, where we put all the data together. We could take a no pooling approach, right, which is sort of doing the opposite thing. So rather than sort of estimating the national vote share, we might sort of treat our data as if it comes from 650 separate mini polls using data from each of the constituencies, and then we sort of just estimate the average level of support for the Labour Party and the Conservative Party in each of the seats, and work out what the election result will be. Now that has the advantage that it will help to pick up on these sort of idiosyncratic features of each local race that are different from the national trends. But the disadvantage, of course, is that we only have a very small number of observations to do that, right? So we only have 150 observations in each seat, which means that we'll have very high levels of sampling variability, right? So if we were to repeat this process, if we different 100,000 observations, we might get very different results in the different seats, because we'll have this because we only have a very small number of observations in each seat. So instead, what we do is to take a sort of a compromise position between these two approaches, what's known as the partial pooling approach, where we'll sort of use the national vote estimates from the complete pooling approach to form a baseline, but then we'll use the sort of constituency level data to tell us how likely it is that local swings are going on. And so in some sense, what we're doing is striking a balance between these two approaches. We're going to try and pick up on the local context whilst minimizing the sort of the sampling variability issues. The disadvantage of this approach is that it's harder to explain. So I'm going to take a little bit of time just to quickly explain what we do. And in some sense, you need to just think about what are the important quantities that we need for predicting election outcomes. And I think there are 3 of these. Okay, so the first is we need to think about the population as being constructed of different types. And we want to know how many people are there of different types in the UK in each constituency. So here, a type of person is going to be a person defined by a kind of a vector of their covariates. So you could think of a type as being, a male who is aged between 30 and 40, who has a university degree and lives in Hertfordshire. So I'm a person of that type. How many people of my type are there in the country? And how many people of my type are there in each constituency? So that's the first thing I need to know. And I need to know that for all of the different types of people that you could possibly imagine. Okay? Then for each of those types, we want to know 2 things about them. We want to know what's the probability that they turn out to vote for each voter type, And then what's the probability, conditional on turning out, what's the probability that they vote for each party? Okay, we need to know sort of the probability of turning out, because of course the set of people who turn out to vote in an election are very different from the population as a whole. Not everyone votes. In the UK, it's only about 60% of people who vote. And the 60% who vote are very different from the 40% who don't vote. And then we need to know, as I said, so not just sort of whether they will vote, but who they will vote for. And once we know those three quantities, once we know the types of people in each constituency, how likely they are to vote and how likely they are to vote for each party, we can sort of aggregate across those quantities to forecast the election outcome in each seat. So the approach that we use is known as multi-level regression and post-stratification. It's a big name for a simple thing, but it's a relatively new approach to sort of modeling survey data of this type. And really what it's going to allow us to do is to estimate the number of voters turning out for each of the parties in each constituency, even when we have a relatively small number of observations. Now, of course, this approach, as any approach that you would learn on the MSc degree, is subject to a number of assumptions. Now, I'm not going to go over all of those now, but it's safe to say that we're making a whole load of assumptions about voting patterns in order to generate these estimates. But the basic sort of approach is that we're going to construct what's called a post-stratification frame. So this is basically, we're going to take census data and work out from that census data how many voters of each type live in each constituency. So as I said, we want to know how many people who are male, 30 to 40, and have a university degree living in Hertfordshire. We also want to know how many women there are who are in their 60s, who don't have a university degree and live in Scotland, and so on. So we're going to use the census data to work out sort of what the population looks like. And then we're going to use two joint regression models to determine how likely it is that each type of voter will turn out to vote and how likely it is that each type of voter will vote for each party. So let's just walk through a quick example. Well, we might imagine that we want to know how a woman who's aged 31 to 35 with a university degree who voted Remain for the Remain side of the EU referendum in 2016 and for Labour in the prior general election in 2015, and who lives in the constituency of Canterbury. Well, once we've got the proportion of voters in Canterbury who are of that type, and we know how likely it is that voters of that type will turn out to vote, and how likely it is that voters of that type will vote for each party, then we can just sort of do that same process across all of the different types of voters and across all of the constituencies, and then we just aggregate up to work out what the implications are for the election overall. So this is a long explanation of kind of what it is that we do. Here are the results. So these are the results that we posted the day before the election. We put these online, try and be open about this. Prediction is something you should be doing in advance. We predicted that the Conservative Party would win 302 seats and the Labour Party would win 269 seats. Okay, so here is that the Conservative Party had fewer than 326 seats, so they wouldn't get an overall majority in Parliament. We predicted that they would have to form a coalition of some kind in order to govern. We also, it's worth remembering that we don't just predict these sort of overall headline figures of the result. We also predict sort of the outcome in each constituency. So here's the predicted outcome for Canterbury. Canterbury is a seat that had been held by the Conservative Party for a very, very long time, for many decades. We predicted that the Labour Party would win 45% of the vote in that seat, and the Conservatives would win 42% of the vote in that seat. And so therefore we predicted that Labour would win the seat of Canterbury. Okay. This is important because it was unexpected. Okay. Now, when we posted these predictions online, lots of people thought that we'd made sort of bad modeling decisions. Essentially, they didn't believe us. So here are a couple of tweets that people had sent. So one by Jim Messina, who was one of Obama's campaign strategists and then worked in UK politics for a while. He said that he'd spent the day laughing at yet another stupid poll from YouGov, so that's us, so it's always nice to be laughed at online. Similarly, Ian Dale, who's a political commentator in the UK, said, if you want a good laugh, click on YouGov's constituency prediction page. And he was particularly pointing at this result in Canterbury, this one that I showed you here, as being very silly, sort of saying that there's no way that Canterbury is going to go to the Labour Party. Now, of course, I'm only showing you these tweets because we were right and they were wrong. So here's the actual result of the election on the right-hand side of this graph compared to the predictions from our forecasting model on the left-hand side of the graph. So We didn't get the numbers exactly right. We predicted that the Conservatives would get 302 seats versus 318 in the actual election. And we predicted that Labour would get 269. They actually got 261. But you can see that we were very, very close on the overall aggregate numbers. And crucially, we predicted this fact that the Conservative Party wouldn't win a majority of seats in Parliament. And that in fact was true. And so we predicted this very surprising result. We'd also done pretty well on predicting sort of the relative levels of support for each party across the different seats. So this graph shows you on the x-axis gives our pre-election estimate for each constituency in the country, and the y-axis gives the actual result of the election in each constituency in the country. And what you can see is that in general, those points fall nearly on the 45-degree line, right? So the 45-degree line is where we got it exactly right. You know, not all the points are on that line, but they're pretty close. Okay, so we did a good job of explaining where Labour did well and where they were going to do poorly. And so the same for the Conservatives. This is the one I'm most proud of, which is the outcome for Canterbury. So as I said, this was a very surprising prediction because Canterbury had always been a very safe Conservative seat. We predicted that Labour would get 45% of the vote versus 42% for the Conservatives. It's actually a bit closer than that. They got 45% of the vote and the Conservatives got 44.7% of the vote. But nevertheless, we got sort of the qualitative the qualitative outcome correct, and that we predicted that Labour would win the seat, and they in fact did. So, you know, this is, in some sense, this is very silly. You know, I'm mostly using this just to show off that we did well in this one particular election. And you may be thinking, well, I don't really care about that. You know, this may be sort of predicting elections is kind of fun, but it's maybe not the most important application of this methodology. The good thing is that there are actually many applications of MRP which answer other sort of important public policy questions. So you can think about, you know, the technology that I've just described. You know, we could use that to estimate local public support for different government policies, which is very important if you're interested in sort of democratic responsiveness or representation. You know, sort of, are policies serving the areas that they're meant to serve? Are they sort of congruent with constituent desires and so on? More practically, we can use this kind of technology to do things like predict how much need a given area has for emergency supplies during natural disasters. This has been done recently for things like earthquakes, like trying to work out which areas are most affected and which are most in need of different supplies. During COVID, this exactly the same types of techniques have been used to estimate how prevalent the disease is in particularly small areas of different countries. So not just trying to work this out at the national or regional level, but really narrowing in down to much more local levels, or indeed for understanding something like local patterns of migration. So you can kind of think that there are lots of different types of things that you might be interested in where you could use a tool like this. And kind of more generally, when we think about the methods that we cover on the MSc program, we're trying to give you a set of tools that can then be used to serve your interests, right? So to serve the policy interests that you have. So if you have some applied area of public policy that really sort of motivates you, then it's almost certain that at least some of the tools that you'd learn on this MSc program are going to be directly relevant to making a contribution to that policy making area. So in having some kind of understanding of what we're going to do on the degree, and now I'm very happy to take questions, but I think we'll go over to Dennis first if he's still there. I know that there was some problem with, I think, Dennis, are you there? He seems to have disappeared.
Yes, Dennis has got a problem with his plumbing, so he's had to deal with it. So do you want to dive straight into?
Yeah, that's fine.
And if you need, just feel free to call me if there's anything you want to clarify.
Sure, that's fine. When Julia says he has a problem with his plumbing, that's not a metaphor. Like he really does have a problem with his plumbing. I think that there was in his flat there was some water coming through the ceiling. So, should we take questions first, or should I just go straight on to talking about the degree program in a bit more detail?
Should we dive into the program overview, and then if anyone has any questions about the taster lecture, feel free to drop them in the chat. And what we'll do is we'll have a nice Q&A session once we've just gone through this. Okay,
great. So I'll give you a bit of information about the program overview. I'm not Dennis. Dennis is gone. But let me talk to you a bit more about the program. Some of this I've already said, which is, you know, we are very excited about this degree program, not least because it's a joint venture between political science and economics. And part of the reason for that is that these departments are really sort of major players in the UK university scene. You know, the Department of Economics, sort of very well respected department. It's ranked #1 in the most recent Research Excellence Framework. So for those of you who don't know what that is, the REF, the Research Excellence Framework, sort of awards universities with rankings according to their research output. And the Department of Economics sort of routinely comes at the very top of that list. So it's a very productive research department, and lots of very good people there doing interesting work on different aspects of economics and public policy. They're very successful in attracting sort of research funds, and they have sort of close connections with various other policy-making bodies in the UK, such as the Institute for Fiscal Studies, which is sort of located right at UCL as well. So it's a leading policy research unit. They've also got SEMMAP, which is a centre that combines research in data science and economics with applications to policy analysis. So this is a very, very strong department, full of lots of good people doing lots of interesting public policy research. So it's great that, you know, the degree is half located in the Department of Economics. Similarly, the other half of it is located in the Department of Political Science, which again is a very sort of very strong department, which is very productive in research terms. Although it wasn't ranked #1 in the Research Excellence Framework last time around, it's going to be this time around. Pretty sure about that. At least I hope that's true. But again, there's lots of people working there in lots of different areas of public policy and doing productive and interesting work. It's also just a huge department. So in political science, we offer sort of 10 different master's degrees, which means it's one of the biggest politics graduate programs in the UK. So you've got lots of different people working on lots of different interesting areas of public policy. So again, sort of anything that you could be interested in public policy will be well served either by the Department of Economics or by the Department of Political Science. And then more generally, both of these departments are also collaborating on a new UCL policy lab, which is going to be launching this year, which is a vehicle for promoting UCL's political and economic research, and is really going to make it, I think, make these two departments the go-to place for policymakers who are seeking sort of academic expertise in different policy areas. And so if you're joining the program, it's a very exciting time to be coming to UCL, because there's a real push to sort of integrate data science and public policy tools together, in a really very practical sense. Like we're really trying to provide as much expertise into the real world of policymaking as possible. So I think it's a fun time to be coming to UCL. So what will you gain from the MSc Data Science and Public Policy degree? Well, I've already spoken about some of this, but you can kind of one of the major advantages is that you're going to be receiving training from some of the leading researchers in these fields. So researchers in data science, economics, and in political science. So you're obviously going to learn a whole roster of state-of-the-art data science methods. So we'll cover a very wide variety of different methods. But we're going to combine that learning of those data science methods with the sort of conceptual and analytical concepts and skills from both political science and economics as they're used in policy analysis. So it's not going to be just the case that you'll come just nothing machine learning. We're also going to be sort of how to think sort of rigorously and analytically about policymaking problems using these different approaches that exist in these two disciplines. And the idea is to sort of combine those sets of skills to provide important quantitative answers to policy questions. So as a part of that, you're obviously going to sort of learn about statistical methods, how to implement statistical methods using different programming packages. We're mostly going to work in the R programming language. But you're also going to learn sort of some of what's thought of as the more mundane stuff about data handling, data wrangling, data visualization, these kinds of things. But actually, those are crucial if you actually want to build a career in this area. You need to be able to learn, not just know how to implement some fancy machine learning method, but you also need to know how to get from the inception stage of a project where you come up with the idea, to collecting the data, to organizing the data, to cleaning the data before you can sort of run your model. And so we're going to sort of deal with that entire process, so sort of from beginning to end. And so you'll have a lot of sort of very direct hands-on experience with real-world data in order to answer these kinds of questions. And then at the end of the program, you're going to have a dissertation project where you will come up with your own research question, in the area broadly defined of public policy, where you will be expected to undertake independent research, where you will gather data and implements one of the kind of the data science methods that we've covered on the course in order to answer substantive questions. And so we think that by the end of this program that graduates will really be very uniquely equipped to answer these kind of important public policy questions using data science tools. You know, I really don't think there is a comparable degree program out there at the moment which offers this combination of different skills. I can talk a bit about the structure of the program. You know, there are two routes. There are two different sort of pathways through the program that you can take. One of them is on the economics side, and one of them is on the political science side. So when you are applying, which you can now do because applications are open, when you're applying, you choose which route you want to follow. So you'll choose whether you want to come in through the economics route or come in through the political science route. And each of those routes has slightly different requirements and slightly different expectations when you enter the program. And then you also sort of take slightly different courses as you progress through the program. And I'm going to talk to you in more detail about the program structure in just a second. But the idea behind having routes is that it allows students to specialize in the areas that are most interesting to you. So if you are most interested in sort of the application of economics tools to public policy, you should take the economics route. If you're more interested in sort of political science, then you should take the political science route. The good thing is that sort of whichever route you take, you'll be sharing some core modules, and then you will probably be sharing some elective modules in the second term as well. So in the core modules, there's, in fact, I'll talk about these in more detail in a second, but the shared core modules is a core module in statistical learning, a core module in programming, and then a core module in what we're calling data, evidence, and public policy. On the elective side, there are then some courses in things like quantitative text analysis, causal analysis, data science theory, and so on, which you'll be able to take, you'll have a choice of which ones you take in the second term. So you have those sort of shared components, but then you also have separate sets of electives. So the political science students will be able to choose from a very broad array of different substantive courses that we offer in political science. So things like public management, health policy and reform, energy and climate policy, global public policy. And the students on the economics route will be able to select from things like environmental economics, behavioral economics, economics of development, macroeconomic policy, and so on. Okay, so there's a combined component of the degree, and then there's also sort of a separate component of the degree that is dictated by the route structure. So let me just give you sort of a bit more detail about how you can expect to progress through this program when you join. And so you know, the year is split into 3 terms. There's the first term, which runs from sort of, you know, late September up until late December. There's the second term, which starts in January and ends in, I guess, the end of March, beginning of April, something like that. And then there's the summer term, which happens sort of from May onwards, or from late April onwards. So in term 1, everyone coming into the program, whether you're on the economics route or on the political science route, everyone will take a core module, which is labeled here as statistical learning for public policy. Okay, so this is a 20-week core module. So this will actually stretch over terms 1 and terms 2. That is which gives you sort of the foundational understanding of statistical learning tools. So this is going to take you on a sort of a broad overview of a lot of different tools, starting from things like linear regression, thinking about logistic regression, different classification methods like naive Bayes. We'll think about resampling methods like sort of the bootstrap. And then we'll go on to sort of more advanced classification tools, things like support vector machines, and then more advanced machine learning methods towards the end of term 2. Now that core module really acts as the basis of all of the other data science modules that you'll cover during the degree, and so we think it's important that everyone takes that. Also in term 1, you'll take statistical programming for social data science. So that's a module that will introduce you to the R programming language and will encourage you to think not just about sort of how to implement models, but also how to do things like data collection, data cleaning, and some data visualization as well. Okay, so that's another core module that we think is important for you to have, because not everyone coming into the program will have programming experience. Some of you will have programming experience in different languages. So some of you may know Stata or MATLAB, or God forbid, SPSS. And then you will sort of come on to, you know, the idea is to sort of introduce everyone to the R programming language, which is what we're going to teach in. And then the third core module in term 1 is data, evidence, and public policy. Again, that's a module that is shared by everyone. And that module is going to sort of, it's not an applied data science module, right? You won't be doing any programming during that course, but rather you'll be thinking about the ways that data science tools are used in the contemporary policymaking process. So the idea here is that we want to explore the types of issues that are associated with using these tools and with using big data in modern public policymaking. And so that might include things like sort of workflow issues. So how do you actually incorporate this kind of evidence into the policymaking process? It might include ethical issues. So what are the kinds of issues that arise that we need to be careful about, or we need to think more deeply about when using this kind of data, and so on. And so it's a broad conceptual course, but I think again one that's very important for people who are interested in taking these kinds of approaches and applying them in the real world. So those are the shared components of term 1. Then if you're in the economics route of the program, you will also take one of the core modules from the economics MSc degree program. So that will either be microeconomics, macroeconomics, or econometrics. So those will be again, that's for economics students in term 1. If you're on the political science route on the program, you'll take a module called the politics of public policy. And this is again a module which introduces you to the analytical skills necessary to analyze policy-making questions from a political science perspective. So you can sort of see that in term 1, the economics route studies kind of the analytical skills from an economics perspective, and the political science route students study the analytical skills from a political science perspective. So that's term 1. In term 2, we give you a lot more choice. So in term 1, you essentially have no choice. You have to do these things. The economics students have a bit of choice over whether they do micro, macro, or metrics. But in term 2, we give you a lot of choice. So everyone will take one elective from from a set of options in data science. So I'm going to try and remember them off the top of my head because they're not written here. So the electives that are going to be available to you, the data science electives that will be available to you are quantitative text analysis, which is exactly what it sounds like. It's a module dedicated to the quantitative analysis of text data. Causal analysis, so that's thinking about data science methods that allow you to draw causal inferences about the effects of some phenomenon on another phenomenon. Data science theory, which is a more mathematical exploration of the tools that you'll be learning on the statistical learning for public policy module. So that module, the statistical learning module, which is sort of compulsory for everyone, that's a very applied module. There will be some mathematical detail in there, but if you want a deeper understanding of the mathematics behind these modules, then data science theory is the elective that you'd take in term 2. There's machine learning in economics, which is using some of the sort of more recent innovations in machine learning, which you'll be learning about in the statistical learning module as they are applied to questions of public policy making. And then there is a fifth, which is time series econometrics, which is a sort of analysis of time series data using data science tools. Okay, so you have you will select one of that broad set of elective modules. So you could choose the kind of data science approach that is of most use to you. If you're in the economics route, then you will certainly take machine learning in economics. That would be a compulsory module for you, as well as your the elective that you take from the shared pool. And you'll also take another elective from the substantive options that are available in economics. So those are the ones I spoke about earlier, about things like macroeconomic policy and developmental economics or behavioral economics and so on. In the political science route, you take 2 substantive electives from political science. So you might take trade policy and management and regulation, or something like that. Okay, so you have the choice to sort of guide your own interests. So whatever area of public policy interests you the most, you can take modules in that area. And then in term 3, you will take the dissertation. So there's no sort of additional modules to take in term 3. Your whole focus will be on producing an independent piece of research using, combining the substantive knowledge from your political science or economics modules with the data science skills that you've been learning in all the shared modules. Okay, I think that's all I have to say here. Oh no, there's one more thing, which is how to apply. It's actually quite an important thing. Okay, so how do we apply? Applications are now open, so you can apply online. The application deadline is the end of March 2022. And it's worth saying that sort of what we're looking for really here is students with a very strong analytical skill set. Some of the modules are technically demanding, but the entry requirements really depend on which route you're applying for. Okay, so if you're applying to the economics route, then you are expected to have at least an upper second class BSc degree or BA degree from a UK uni or whatever the overseas equivalent is. And you should either have done an economics program at the undergraduate level or some other quantitative discipline, so statistics or mathematics and so on. So you do, for the econ route, you really do need a very strong quantitative background. If you're from a non-UK degree, then you need to supply your GRE scores, the general test scores, and your quantitative GRE score has to be at or above 161. The other thing that I forgot to mention on the previous slide is that the economics route students have to pass an online maths camp during the summer. So there is a higher sort of mathematical hurdle to pass if you're on the economics route than if you're on the political science route. If you're on the political science route, then we also expect you to have an upper second class undergraduate degree from a UK uni or whatever the overseas equivalent is. And we expect you to have completed at least one module in quantitative methods during your bachelor's degree. Now, it's worth noting, if I show you the program structure again, there's a lot of quantitative material to be covered in this degree program. So if you have only taken one undergraduate course in quantitative methods, you should expect to work very hard, certainly in term one of the degree. You're going to have to work hard anyway, but it's worth being aware of the fact that this is a demanding program, and so you'll be most comfortable if you've taken more than one quantitative methods program, but we will consider applications from people who've only taken one.